Um, in this video, I will just try to work out the solution for these two integrals. I'm asked to integrate x multiplying the square root of 1 plus x squared with respect to x. That's the x. This is an indefinite integral, and I have a definite integral here, right? I can't overemphasize in this video certain principles or rules, but I recommend you go through my channel. There are certain further math questions that will really help you. First of all, in solving this, the first thing I'm going to do here, the approach that I'm going to be taking that will help me get the solution a bit faster. There are a couple of different ways this could be done, but what I'm going to be doing here, as far as I'm concerned, I'll be using the U-sub, that is the U-substitution method, right? I'll be using the U-substitution method for this integral here. I will let U equals to 1 plus x squared, right? That's 1 plus x squared. That's all that I have under the radical. 1 plus x squared. That's what I will let U equals to. Now I have to find the U with respect to x. I'll try to differentiate U, which I've said 1 plus x squared with respect to x. Differentiating 1 gives us 0. That's differentiating a constant gives you 0, right? I cannot prove it here because of time. So if I differentiate x squared, which will gives me 2x, right? X squared will give me 2x. So differentiating all of this stuff, you will remain with that of 2x will be your remainder. So I will now solve for the x, make it the subject, as how best I'll be able to replace this dx that I have here in the original question. So I'll cross multiply first thing. Du times 1 gives me du, which is equals to 2x times dx. 2x times dx. Now I want dx on its own side, so I'm going to divide both sides by 2x. I will divide both sides by 2x. I have seen it clearly that 2x will cancel out 2x on this side, and I will have du upon 2x will be now equals to dx. I'm fine at this stage. I've already get my replace for this dx here, and I've already make it clear that u is equal to 1 plus x squared. I will now replace 1 plus x squared, all that I have on this radical, as u. So this is what my expression will look like. My expression will now look like the integral of x, the square root of u, the square root of u dx. But this of my dx, I've already solved for it. Dx here is equals to du upon 2x. So I'll replace dx here with du upon 2x. I'll now have the integral of x to the square root of u du upon 2x. I'm still fine. I can as well rewrite the square root of u here as the integral of x u to the 1/2 du over 2x. Please go back to your indices rules. This square root of u can also be written as 1/2. Please, you need to keep track of that, please. The square root is always taken as a fractional exponent. 1/2, please. You need to keep track of that. So as far as I'm concerned now, it is clear that this x will cancel out this x. They are gone. Now I have the integral of u to the 1/2, the integral of u to the 1/2 du upon 2. These two here can also be written as 1 upon 2, the indefinite integral of u to the 1/2 du. I've just taken out the constant and then leave u to the 1/2 over du. I will now integrate, right? I will add 1 to this power, which is the 1/2, and divide by that new power now that I've got, which is 1 upon 2 plus 1. 1 upon 2 plus 1, I add 1 to the power, and now I'm dividing by that new power. Keep track of what I'm doing here, please. Next, I still maintain my constant outside, 1 upon 2, the integral of u, 1/2 plus 1. If I simplify it further, I'll have 3 upon 2, and then all over 3 upon 2 du. The next step, at this stage of maintaining the constant out, I still have the integral. After simplifying, remember this denominator that I do have here, I will reciprocate it and then switch the sign to multiplication sign. I will now have 2 upon 3 u raised to the 3 over 2 du. I'm still fine at this stage. 1 times 2 maintain me the 2 there in my numerator, and then 2 times 3 gives me 6. I have now the integral with no constant at the front. 2 upon 6 u to the 1 u to the 3 upon 2 du. If you simplify further, 2 here into itself 1 times, into 6 3 times, and I will now have the integral of u to the 3 upon 2 all over 3 du. Now it's fine that I will have to replace u to my original operation, which was that of the x. You know, u, we said it is equals to 1 plus x raised to the power 2, which we later differentiate, which gives us 2x. So we are going to take this original and then plug it and then omit that of u. So that's what we are going to do, and then fix our constants. Therefore, the integral of u to the 3 over 2 all over 3 du will now be equals to, I'll replace u with that of x, replacing u with x, which will now give me the integral of 1 plus x squared to the 3 upon 2, remember that's my u, all over 3 plus c. This is my constant here of integration of the indefinite integral. This is my answer.